Hi, my name is Emily and welcome to our Sustainable Design Challenge video, where me and three other juniors designed an eco-friendly market called Solus. First, going on to Maddie with transportation and sustainable sites.
Hi, my name is Madison, and I'll be presenting our transportation and sustainable site features. To maximize the availability of sustainable transport options, the front of our building includes a variety of plants, benches, and bike racks to encourage walking and biking. In order to promote public transit, a city bus stop is located a short walking distance away, and the Elmhurst Metro Station is located around a mile away. If none of these options are available, our parking structure features car charging stations for electric cars as a greener alternative to gas cars. To reduce the heat island effects of the building, the roofs feature a green roof over the parking structure and a high albedo cool roof covering the store. To pave paths and roadways, we use permeable pavers as well as cool pavement made out of recycled aggregates to sustain lower temperatures than traditional asphalt or concrete. Finally, the lush trees and plants surrounding the entirety of the building provide shade and cool the air through evapotranspiration. In order to prevent light pollution, all exterior light fixtures, both mounted on the side of our building and placed next to paths, utilize warm LED bulbs that face downwards to direct the resulting light towards the ground and to reduce unnecessary illumination. This lighting also utilizes shields that block the light from going upwards, and this helps to reduce light trespass. Exterior lighting is only ever turned on when it's night, and is turned back off when the environment is naturally bright again. This is accomplished through the use of automatic lighting system timers in combination with motion sensors that turn on lights only when people are nearby. Our building is constructed in Elmhurst along Salt Creek, which is a north-south running stream located on the west side of the city, and then this is incorporated into the exterior of our store. The site is a brownfield and was previously a gas station that left parts of the land contaminated with pollutants. After remediation, the construction of the store includes much of the existing landscape as possible, and to further protect the surrounding ecosystem, native vegetation is introduced.
Now let's dive into stormwater management. Permeable pavers and pervious concrete surround the outside of our building, as shown on the model. They allow rainwater and snow to absorb into the ground, reducing flooding and filtering pollutants as the water seeps into the soil below the concrete. Lush native vegetation is planted both on the ground and on our green roof to retain rainwater as it falls from the sky as well as off of the sloped roof of our store. Rain that isn't absorbed into the earth is likely caught by our rain barrels and basins, which are shown set up along the perimeter of our model. This water is later recycled to water our indoor and outdoor vegetation. Our cistern, located underground, is able to hold mass amounts of rainwater. The large amounts of water that it is able to collect are used for plumbing purposes throughout our store. Bioswales are located between the roads leading into our parking structure to gather runoff effortlessly and filter it to remove debris and pollution. Sloped trenches are built between our building and Salt Creek to guide the water runoff into a drainage system, which, while also slowing the process, will give the soil time to absorb the water and reduce flooding. Lastly, our rain garden that features the lush native vegetation is able to hold the rainwater as it slowly seeps into the earth. The rain garden is strategically placed on our property at a low elevation point, ensuring water from higher elevations is able to drain into it.
Hi again. I'll be explaining how our building is water efficient. The most important outdoor water reduction method our building utilizes is the xeriscape landscape, which surrounds the building and takes away the need to have an outdoor irrigation system to water plants. These plants are then hydro-zoned according to their sunlight and water needs, further reducing the need to ever water them. However, if any of these exterior plants need to be watered, the building's automatic rain sensors that test the soil will notify employees that the foliage is dry. To water these plants, rainwater stored in the rain barrels is used as well, and gray water is fertilizer. A combination of low-flow, self-closing fixtures, ultra-low-flow toilets with gravity flush mechanisms, and waterless urinals all help to reduce the indoor water consumption. In addition, all toilets, urinals, faucets, and shower heads are WaterSense labeled to correspond with EPA water efficiency requirements. To further reduce water usage, gray water from the sinks and showers gets reused in the toilets so we can reduce wastewater. The ultra-low flow toilet plumbing systems also utilize non-potable water sources, such as the rainwater in the cisterns. To track our water consumption, our building has a smart metering system installed. This system uses an ultrasonic meter instead of a mechanical one to improve reliability and extend low flow accuracy. Smart alarms for the meter provide early detection for flow, pressure, and temperature disturbances, which is beneficial for catching and preventing possible problems.
Hi, I'm Aaron Powers, and I'll be talking about energy efficiency. One of the most important aspects of what makes a building green is its energy efficiency. To power our building, we are using solar energy attained from SunPower Maxion X-Series solar panels on the top of our roof, since it's one of the most efficient and readily available sources of renewable energy. To store the solar energy, we chose the saltwater solar battery because, unlike most other solar batteries, they don't contain harmful metals, meaning they can be recycled. To efficiently monitor the energy production and usage of our solar panels, we chose the Sense Energy Monitor with Solar because it is one of the best on the market in terms of ease of use with the remote monitoring from your mobile device and installation. It also allows access to a wide range of data, such as calculating how much you are saving with the solar setup, as well as detecting energy consumption for each device in your building to help us minimize our energy usage. Our main source of light is natural daylighting, but when that is not an option, our store is lit with UFO LED high bay lights. We have the same lights in the bathrooms, except these are on occupancy sensors, so that when the bathrooms are not in use, the lights will be off to conserve energy. The high bay lights are in a linear pattern spaced 15 feet apart to maximize the lighting per fixture and to fully light the store with as minimal energy as possible. Lastly, all of our lighting can be dimmed so that as the light levels change outside, we can determine how much lighting we want to use inside to minimize energy usage. Because the building envelope is one of the most important aspects of maximizing energy efficiency, we chose to make the walls out of papercrete because it is one of the best and most affordable insulations. On our model, you can see our roof and walls are painted light gray to reflect sunlight to minimize the heat absorption of the building. We also chose to install a steel door because it has a high insulation and is easily recyclable. For the windows, we chose low-E glass because the microscopic coating allows for natural light to come in but reflects heat back to keep our building temperature stable. For the interior of the building, we have insulated window shades, which have the highest R value of any window treatment and can reduce heat loss and solar heat. Lastly, our floors have underfloor insulation, which keeps heat from escaping or entering through our floor. Ceiling fans are a cheap and environmentally friendly way to cool your building and improve air circulation. To keep our building warm, we are using a solar liquid heating system, which uses solar energy to heat a liquid and transfers it to a heat exchanger to be used or stored for later. A similar process can be used to cool our space. The solar energy heats a liquid, but instead of using that liquid to heat a space, we use it to power a thermal activated cooling system, which then cools our building. Next, you will hear about materials and resources.
Hello, I'm Emily, and first I will be speaking about the materials and resources used to create our building in the most environmentally friendly method possible. Specifically, we created carefully designed recycling bins placed methodically around our store with clear signs of how to sort waste. Our composting process used a combination of open bin composting with trench composting. Similar to recycling, we had bins near the front entrance of our store for customers to drop off their excess browns and greens to put in our open bins. For our trench composting, we would use excess produce and grains that were not sold in ample time. To encourage composting, we created the incentive that if recyclables or compostables are brought in by customers, they will be able to receive discounts and coupons on products. For the foundation of our building, we wanted to use a reliable material, which is why we chose papercrete, an alternative to concrete with less aggregates made up of paper fiber, hemp, bits of wood, and sawdust. Papercrete has great heat and sound insulation as well as high compressive strength. Using Armor Membrane 262 commercial waterproof, we found our material would resist freeze and thaw cycles in the unpredictable Midwest climate. Moving on, we dove into all the ways we can improve the indoor air quality of our building. We chose to use all low VOC products certified by GreenGuard, including paints, solvents, and more. Secondly, we used Rainer to find eco-friendly carpeting that used felt padding instead of synthetic fibers and natural and untreated fabrics for furniture. Furthermore, we used coffin manufacturers with low VOC countertops to use materials like recycled glass and paper. To improve indoor air quality manually, we chose to sell a variety of plants in our market to have our own custom interior landscape. We chose to install fans and dehumidifiers around the building in the event that we cannot have windows open. We sought out to obtain an HVAC system and ASHRAE 55 system that would heat, cool, and filter pollutants in our building. Solar gains and external shading systems along the side of our building would provide temperature control as well. Thank you for taking the time to watch our video.